welcome back to PostNetwork Academy. I am Bindeshwar, and in this video we will introduce you machine learning, its definition, types and mathematical foundations. So whether you are new to machine learning or refreshing your concepts, this lesson will help you understand how machines learn from data. So let's start with the fundamental question, what is machine learning? So other question, what are the different types of machine learning? How can we mathematically define each type? So Herbert Simon definition that learning is any process by which a system improves performance from experience. Let us see another definition by Tom Mitchell, and that is a very popular definition about machine learning. A computer program learns from experience E with respect to a task T and performance measure P. So you can see that a learning is three tuples E, T and P. That is by Tom Mitchell. And you can say that performance of T, that is directly proportional to function of experience, and this was defined by Tom Mitchell. He has also written a book on machine learning. Now let us see what is supervised learning. This is one of the types of machine learning. So basically there are four types of machine learning: supervised learning, unsupervised learning, you can say that semi-supervised and reinforcement learning. So the first one is supervised learning. So see that if there are data set D where x1 is, you can say that independent variable, y1 is dependent variable or labels. So you can say that what is the goal? The goal is to learn a function, basically approximate a function fx from this data. Basically you are approximating a function from this data. So this is basically called supervised learning. And basically there are two kinds of supervised learning. The first one is classification and second is regression. Now loss function, let us understand here. In upcoming videos I will explain. So basically loss function is a function that you can say that the level is, this is a data 1 means target target learning, target function and given function, there is the difference. So that difference makes, you can say that, loss function. There would be many values and that values will consist of function, that is called loss function. Basically here it is mean squared error or squared error. Basically mean, when you divide it by n, then it will become mean squared error. So that is squared error. In future videos I will discuss in later, because that is very important, squared error. So I will discuss. So the target one and the actual one, you can say that. So that difference is called loss function. So this comes when you learn classification or regression. So these are two kinds of supervised learning. You can say that types of supervised learning. Now let us understand here, very simple. So here these are the data points, this one, three data points. So you see that if you want to make a straight line, so you cannot, but you can approximate a function having loss function is minimum. So we will see that, but just from the data set you will approximate a function, and that is the key concept of supervised machine learning. Okay, so we will see in the future. Now let us see semi-supervised. So it uses both labeled and unlabeled data. So basically this is a union of labeled data and unlabeled data. And it is useful when labels are expensive to obtain. For example, speech recognition or medical diagnosis. Getting data would be very difficult. So you will use some labeled data, otherwise unlabeled data. So here unlabeled data and labeled data. Now unsupervised learning. No labeled data. Goal is to find patterns. You can see that. There is no Y. So in supervised learning we had x1, y1. So that was data and y was label. Label or class. This is also called label or class, a dependent variable. And in unsupervised learning there is no class or label, only data. What is the objective? Objective is to map here a function from data to cluster here. That means if there are data, so just you will group them, and there are also other tasks like find out hidden patterns inside data. So this is one of the important tasks, that clustering or grouping of data. Examples like k-means clustering and DB scan. So example of here, so if your data twist will cluster in two parts, that is clustering, example of clustering. Reinforcement learning, that is a different kind of algorithm, and this is based on agent environment interaction, and basically it is used in robotics. So here basically you will understand, it observes states, take action, and if action is right, so it receives rewards and moves to the new state. Here you might not understand, but uh, actually this is your agent will interact to environment, and if it works correct, so it will get reward, otherwise receive reward and moves to new state. In future we will discuss more about reinforcement learning, and this is basically used for robotics. And what is the final goal? To receive cumulative reward. Also this formula I will discuss in future. So just these kind of things you must be familiar, and as I told you, it is used in robotics, game AI, and also nowadays large language models are using, LLMs are using with reinforcement learning to improve performance of LLMs. So reinforcement learning is used basically for robotics and also to improve large language models. So we will discuss all things. So basically I have discuss four kind of algorithm: supervised machine learning, supervised algorithm, supervised algorithm, second semi-supervised, third one unsupervised, and fourth one reinforcement learning. So these four kinds of algorithm basically you will come across when you are learning machine learning. So hope you understood. I have also made many videos on statistics and probability, and you should watch them, because if you are going in the field of artificial intelligence, machine learning, data science, so you in future at some point you will see that algorithms are using statistical probability. You will see that linear algebra. You will see calculus, optimization theory, information theory. But these three are base: statistics, probability, and linear algebra and calculus. Optimization theory that uses, you can say that linear algebra and calculus you can understand. Also information theory, probability, it uses probability and matrices. But these are the fundamentals you have to learn to be good at machine learning. So hope you have understood what I have explained. Thanks for watching the video.